Hi, this week we're speaking to Dr. Rietbroek on his recent paper, Revisiting Contemporary Sea Level Budget on a Global and Regional Scales, which was published in PNAS recently. So, Dr. Rietbroek, if you could give us a quick summary of your paper.
Oh, thanks for your invitation. Actually, we know from a lot of measurement that sea level is rising. If you look at tide gauges, for example, who has been installed at our harbors, we see that over the last century we had about 1.5 up to 2 millimeters a year of sea level rise. And since the 90s, we have in fact better measurements of sea level rise, which are satellite based. And these indicated that there has been an acceleration in sea level rise. And now we're currently talking about roughly 3 millimeters a year. However, an important, interesting question would be, okay, this sea level rise, how, by what causes or by what components is this caused? And that's exactly the question we try to answer in our paper. So we took those measurements and tried to split this up into different components. And what we found is that the component due to warming, so essentially the ocean warms and expands, causing a sea level rise, is larger as measured by in situ data in the ocean. So just a rough recap, what is causing sea level rise? We essentially have two different types, mass-related changes. For example, if Greenland or Antarctica melts, it will cause a sea level rise. And on top of that, we have changes in water exchange between the continent and ocean. So for example, if there's more rain on land, it will cause a small sea level drop. Or if aquifers are being depleted, it will cause a sea level rise. Furthermore, wind-driven changes, wind pushes ocean water around, which also causes sea level changes. Then, besides those mass-related changes, we also have volume-related changes, which are caused by, for example, increased warming, which everyone can imagine that if you warm a bit of ocean, it will expand and it will actually go up. And furthermore, on regional scale, so if you look regionally, then changes in density of the ocean, which are caused by, for example, a difference in salt concentration. Imagine Greenland ice sheets dumping fresh water in the ocean will cause density changes. This will also cause volumetric sea level height changes. For local observers, vertical land motion, if the land is going up or down, will actually also cause a relative sea level rise, which may come from uplift, which is still ongoing from the loading of the last ice sheets in the last glacial ice age, or more locally, for example, we have groundwater withdrawal in Manila, for example, causing the land to subside by about 50 millimeters a year. All of these changes are uniform changes. Essentially, because the ocean is not a giant bathtub, it just responds in a slower way than what we would expect from a small bathtub. So changes do not propagate from one part of the ocean to the other one instantaneously. So that's why we can see difference in sea level change. Furthermore, ice sheets cause also gravity changes, which also have something to do with the sea level. So it causes non-uniform sea level changes. So what did we do in our paper? We tried to separate those mass and volume contributions by combining satellite data, essentially two types. First type is radar altimetry, which measures the height of the sea surface by sending out a microwave pulse from the satellite towards the ocean, which then reflects, and then by measuring the travel time, it can actually be used to retrieve the sea surface height. So this is a geometrical measure which measures both volume and mass contributions. On top of that, we have a second satellite type, data type, which is related to gravity changes of the Earth. So these can be measured by the gray satellites, which essentially is a twin satellite, two satellites flying after each other. These essentially measure water and ice movements which take place on the surface of the Earth. Essentially, whenever you move mass around, can be water or mass or atmospheric masses, it will change the gravity field of the Earth slightly. This can be measured by those satellites. So it actually causes small disturbances between those two satellites, the distance between them. To get a feel of the accuracy of this satellite type, I tried to make an analogy with a police officer which would have a laser gun, like just to measure your speed, with the same accuracy as Grace. So he would be able to find or detect you exceeding the speed limit by about 5 microns per second, which is 1/10 of the thickness of a human hair, over a distance of 200 kilometers. So it's incredibly accurate how these changes between those satellites must be measured in order to retrieve those ice and water mass changes. This gray satellite measures therefore only the mass component due to water movement, and by combining altimetry, radar altimetry, and grace, we can actually separate volumetric from mass. So that's what we did in our paper. What we found is that the contribution due to warming, essentially volumetric expansion of the sea, was roughly 1.4 millimeters a year over the last 12 years, which is about twice as large as what is measured by hydrographic measurements in the ocean, which is about 0.7 millimeters a year. So there's a big difference between what we obtained from the satellite data and what people obtained from the ocean measurements. And this is interesting because it might be that those ocean measurements, you cannot sample the entire ocean everywhere, especially in the deeper part of the ocean. We have not that many measurements, that those measurements may have overseen some of the signal. So this is an interesting question which came up in the paper. This warming component is important because it tells us something about the heat which is absorbed by the ocean. This is of course a very important climate indicator. It's interesting to note that there are some models which actually indicate also ocean heat uptakes which more or less agree to what we find. So in effect, this study is very interesting because we can use it to validate climate models. This can be done in particular well because we are now able to separate those contributions, separate mass from ice sheets from warming contributions in sea level. Finally, what we also found is we are also able to split up the sea level budget, so to say, so try to decompose these contributions in different contributions, also on a regional scale. And what you will find is that compared to the global mean, this division into these different components can vary quite a lot from place to place. As an example, we found in the Philippines a very strong warming signal, total about 15 millimeters a year, which is about 5 times that of the global mean rise. And most of that is caused by warming signals. So by comparison, in the North Sea, which is quite a shallow sea, we only find about 1.4 millimeters a year over the last 12 years. And this is less than the global mean. Important factor in the North Sea is that a lot of wind-driven effects, essentially pushing water in and out of the North Sea, actually cause a lot of variability in the sea level in the North Sea, which also is reflected into the uncertainties. So in a nutshell, what we did is we were able to divide sea level change as measured by satellites into different components on both the global scale and also on the regional scale.
That's great, thank you. So just wondering, why does the major contributing factor vary across the world?
The major, well, actually, the contribution from mass and from warming has about the same order of magnitude. If you look at the warming signal, you see that there's a lot of variation depending on where you are, and this is due to the fact that the ocean does not respond instantaneously to changes in density. So if you warm one part of the ocean, the sea level will rise, but these changes will not travel that quickly from one basin end to the other basin end. So it means that there's kind of a delay in what's happening in the ocean. And this actually causing regionally varying sea level rise. Concerning the mass part, we also see a regionally varying signal. So if you're close to the Greenland ice sheet, for example, you see that sea level will actually drop in the vicinity of this ice sheet. And in the far fields, or far away from the ice sheet, we'll actually see a sea level rise which is larger than the global. And this is mainly due to the gravitational effect in combination with the deformation which is caused by this ice sheet is loading on the solid part of the Earth. This will actually cause an elastic uplift. If the ice sheet starts to melt, the crust will move upward a bit, and of course this will influence your relative sea level rise as well. So depending on where you are, these effects are different.
Okay, and also the rate of the sea level appears to have risen in 2011, but it's much more stable since 2013. Do you know why that is?
So generally, we considered 12 years of data, and this in fact is not a very long time to consider sea levels or long-term sea level changes. However, we are limited by the availability of our satellite data. Even within those 12 years, you see a lot of variations, which might come from natural sources, like, for example, the big El Nino La Nino cycle. It will cause fluctuations of sea level. So if you look into a 12-year time series, you will see fluctuations. Sometimes it goes quicker, sometimes it goes slower. These are interannual fluctuations which are visible in sea level. So the best thing we would like to have is to extend sea level time series so that we can try to remove those year-to-year fluctuations.
That's great, thanks. So what's next for this research, other than obviously expanding it for more years?
That will be one important point. The other important point is try to add additional data sources. I already discussed about those in situ data. I think it's very interesting to see how we can join such in situ data as well, to see if we can explain more on where this additional warming is coming from. Is it coming from the deeper part of the ocean, or are there certain places which are not very well sampled which are causing this? So this is an interesting thing to do. And the other thing to do is that we try to zoom in. So from global scale sea level, we talked about regional scale sea level. However, if you're starting to look at local measurements or local tide gauge measurements, they can differ quite a lot of global and regional sea level. And the challenge is to try to reconcile those local measurements at local scales with those larger satellite scale measurements. So that's an interesting topic for the future.
That's great, thank you so much. It was really interesting. We'll put a link to the paper, which, like I said, was published in PNAS, and we'll put it below this video. Yep. Thank you so much for joining us.
Thank you.
Bye.
Bye-bye.